So I will have a very simple introduction. Electric network theory. In the electric network theory, we deal with two main quantities. It's the voltage and the current. I need this one. The voltage or potential is the same word. Most of the time we use voltage, but in the text can be used as a potential. And the current. In this circuit theory, we are working to calculate the current in the different branches and the voltage on different nodes, or in the power system, the buses or the transmission line currents are very important for us to be calculated. So what's the voltage and the current? So as we know, current flows because of the voltage difference. So voltage difference is the force that create the current, and the charge carrier follows through the branch. But for us, it's important to know that voltage is defined across the element. It's a symbol of the simple element in the circuitry, and the current, it's entering the element. And the network is generally collection of such element. For example, we have different resistor, capacitor, inductor, and the generation. So combination, all of them will be a network that we would like to be analyzed. But we have two important concepts, loop and node. What is loop? The loop is any closed pass through two or more elements, the power system. For example, here we have 3, but it's possible you have 2. Is 2. So minimum we have 2 elements to create a loop. And here we have 3 elements. However, what's the node? This point is called node. And at the node, 2 or more elements are interconnected. Consider that we have 3 elements that interconnected here. But we can have 2 elements as well. And this point can consider as a node. But it's very simple because the current is very important for us. The current on the both sides of the node are the same. So it's not very useful to analyze this point. But here is the interconnection of the 3 lines. We have line here, here, and here. So it's important for us to analyze this node. 2 fundamental laws of network theory. Can you tell me which kind of laws we have, the basic? Who was that answered the question regarded to DC system, the problem? I forgot the name.
I think that was me.
Harald?
Yeah.
Yeah, good. So can you answer the next question?
Well, we have the Kirchhoff's laws, like the voltage law and the current law.
Yes. Yeah, that's right. We call it KCL and KVL. And different guys pronounce differently. I call it Kirchhoff, different pronunciation. But we have KVL and KCL. For example, for the KVL, it's the principle we have. I can say you can analyze all the circuit with these 2 principles. With the KVL, we can say in any closed loop of network, the sum of all voltages in the same direction are 0. So you have to start from one point. For example, you can start from here. It's common in the analysis that you consider one point as a reference. You consider as a 0 voltage, and for example, start from here. But you have to, we have to go in one direction. For example, here, if you go in this direction, you will have 1, V1 plus V2 plus V3 will be 0. Or in the mathematical form, we can use sigma. Vk, from 1 to 3 will be 0. It's called it KVL. But the KCL, it states that any node in the network, the sum of all current entering the node is 0. The word entering is not very important. The important thing, you have to use a constant direction. You can consider all the entering or all the leaving. For example, here, for this node, I1 is entering to a node. I2 plus I3 is 0. It's the KCL. But you have to fix, you have to consider a fixed direction for the current at the start of your analysis. If you, for example, consider this line for I2 and this line for I1 and this line for I3, we have the same equation. Consider the equation, consider the direction is very important. Keep it constant during your analysis. It's a KCL. Network element affect voltages and the currents in 3 ways. For example, we have voltage source. In the voltage source, source constrain the voltage across the terminal as a fixed value. We have different type. We have dependent and independent voltage source, but now consider it is independent, and the voltage across the terminal always is constant. On the other hand, we have the current source as well, independent current source. When you have a current source in the branch, so we can say the current through the branch will be constant value. So, for example, if you had a circuit, for example, here, or if you had capacitance here, through the loop, current is always fixed. So because of we have the fixed current. Okay, but we have other element as well. Suppose that we have the resistor, we have the capacitor, inductor, we have different expression for the different components. In the resistor, we have these laws. We call it Ohm laws. Is very fundamental. That V is written R times I. It means that voltage across the terminal of resistor will be R multiplied by the current through the resistor. The voltage divider, it's a useful trick that can be used. Suppose that you have a very big circuit and you want to analyze it. We have two principal voltage dividers and the current divider. You can use them to increase the speed of your analysis. So it is useful for you to analyze the system, analyze the network better. I want to show you how we can extract the formulation. Consider this network system, we have one loop and 3 nodes. We have nodes here, here, and here. But we can write this equation based on KVL. If I started from here, go in this direction, or started from here or this direction, will be the same. For example, if I started from here, I can write minus ys. I'm going this direction. Plus v1 here and v2. If we can write it, it will be the KVL. So you can see the same, but it's the whole expression is multiply minus 1. It's the same because it started from this direction. If we want to write a KCL here, eraser. So we want to write a KCL here. We can write I1 is entering, but I2 is leaving. So it will be minus. I2 will be 0, right? As you can see here. How about what are these parameters? V1. V1, according to Ohm laws, will be R1 multiplied by the current throws branch will be I1. And the V2 will be R2 times I2. You can see here. And if we want to write VS, you want to rewrite this one, we can write VS will be, oh my God. I hope the next session will be physical. VS will be Y1 plus Y2. And VS will be R1 I1 plus R2 I2. And here you can find VS R1 plus R2 times R1. And the final equation will be V2. VS R2 over summation of R1 and R2. So when can we use? If I give you this equation, this diagram, and ask you the expression for V2, it's not necessary to write the KVL and the KCL. You have to use this expression for calculation. You want to calculate V2, the voltage across the terminal of the resistor that is in series with another resistor will be the voltage on the two terminal VS multiplies its own resistor R2 and the summation of the two resistor. So please don't repeat all the KVL and KCL, and to increase the analysis and save your time in the exam, use these toolkits. Another toolkit will be current divider. You can see here, I want to show you with the diagram here. It's a simple circuit that we have one source. We have one source and two resistors in parallel. So we can write different equation. We can write here, we have IS here. If we write it, IS will be I1 and I2. The summation comes to other side of the equal. And if we want to, since they are parallel, we can say the voltage terminal are connected. So the voltage are similar for the both resistor. We can write the voltage V1 is equal to V2. So V1 is R1 I1 equals R2 and I2. Since the terminal are connected and the voltage are the same. So we can write this equation. If you bring this one to another side, we will have this equation. But for us, it's important to know what's this parameter we want to calculate. You can see the final result. The current through the resistor, when you have two resistors, R1 and R2, and you have a current source here, or you know the current in this branch, it's not necessary to use KVL and KCL. You have to use this equation. The current, it's written here, is the current source and not its own resistor, another resistor, R1, if you want to calculate the current. Another one over the summation of R1 and R2. It's called it current divider, and it is very useful for analysis of circuit. Do you have question? No. So it seems that you know a lot. Okay, so I have to reduce the presentation. Okay, the serial combination or series combination. When two elements are in series, we have the same current that follow through the both item. We call it the series combination. The current here and the here is the same because they are in the same loop. This combination is called serial or series. And if we want to analyze it, we can write this equation. Suppose we start from this point, according to KVL. I'm repeating just to remind you and get familiar after the long summer. Will be R1 IS R2 IS. In both elements, the current are the same. So we can say IS is R1 plus R2, as you can see here. And if you consider as a R equivalent or R series, it's the combination of two R. It means that it's not necessary to write the equation. When you see two series resistor, it's better to use the summation of them in the serial combination. as it mentioned here, it's possible to lump the two together as a single resistant. It's the same as this one. These two diagrams are the same because we have the serial combination. It should be minus here will be 0. It's correct. And the next one, the parallel combination. Do you have question here? It's very simple. Your 5th semester. Okay, and the parallel combination. When two elements are connected in parallel. So you can see in this diagram, you have R1 and R2 that are connected. We have the same voltage because the terminals are connected. In this configuration, we call it parallels. So you can write it. You can see I it's the I, it's better in this way, is I1 plus I2, because when current comes here, is divided in two parts. One comes here and one comes here. So will be summation of two currents. And I1, this current will be voltage drop you will hear. And the voltage drop will be V1 over R1. And I2 will be V2 over R2. But V1 and V2 are similar because they are parallel. For both of them, we can use V, similar to the main source, instead of V1 and V2. We can write in this equation. And we can rewritten it in this way. And if we want to define and are equivalent, will be, you can see here, according to laws, Ohm laws, we have R, V, it's the Ohm laws. Is it right? We want to make it similar to this. So we can say V oh my God. We can write this in V is 1 over R1 plus 1 over R2 I. This way will be R, and we call it equivalent. You can see it here. It's the same expression. So instead of two resistors in parallel, we can use one resistor. And this symbol is very common for the parallel. When we write this, it means that they are in parallel. And instead of this one, we can have this circuit R1 parallel R2. the result of this analysis is similar to this analysis. So it's the parallel combination. We can combine two parallel resistors in one. But in general, we can say parallel elements. About the loop and node equation, do you have a question regarding to the previous one? No. Since I don't see all the faces, just open your microphone and tell something. The next will be loop and node. Okay, we have two loop and node equation. There are two well-developed form way of solving how we solve the network. According to node equation method, we used KCL. We use KCL in different nodes that is useful for us, and then analyze the whole system. But we will try to write the current based on the voltage. It's very common. On the other hand, we have loop equation as well. We write KVL for different loop. We have to define loop and the current in different loop. And you have to consider that the definition of the current in loop is different from the branch. So suppose that I can show you here. For example, it's one loop, IA, it is another loop, IB. But this current is current that pass from the resistor. Current in this branch, can you tell me which expression can you use? Is it IA or IB? It's I. What is I? Harald, do you want to answer? Not all the question. Does anyone know? Do you think it's the same? So it will be I equals A minus IB. So when define the loop and the current for the loop is different from the current in the branch. So always consider this. There is a different definition. Most of the time, but because of this difficulty, most of the time we use node equation method, and it is more comfortable to apply in the simulation tools in the computer. Most of the software you use the node equation method. So it's very common to use this one, and that's why I select this one and analyze in the next slide. So I want to analyze node this system, this circuit with node equation method. We have to write how many nodes we have in this circuit. Just guess. 1, 2, 3, 4, 5.
3.
Yeah. Other answer?
2.
Can be 1. Okay. I can say Both answers are correct, but we can say we have 1 point here because all of during this branch, the voltage are the same. So we consider this as a one node. Another node will be here. However, we have another node here because this voltage is different. However, for analysis of the circuit, we need two equations. For when we have three nodes, two equations are enough. When you have n nodes, oh my God, sorry. N minus one equation is enough. Can you answer why? Because the third one, the last one, is dependent on the other. So it's a rule. When for example, I can say here, you can see very simple case. Consider these nodes. I have I1, I2, and I3. According to the structure of the system, I write equation and then I calculate one equation for I1. I will write and solve it. For example, the result will be 5. I can solve it with one equation. I will write another equation for I2, and the result will be, for example, 10. Is it necessary to write another equation for I3? No, it's not necessary to do that because we can, because it's depend of the other current. So anyway, when you have n nodes, n minus one equation are enough to analyze. So we have 3 nodes in this circuit, but 2 of them are enough. That's why I said both answers are correct. So we want to write, to use the eraser. Forget this one. Now we will start with okay. If we were in the class, I will ask you to write. Can I do that now? Okay, I'll be writing myself. Pen. Okay, I want to write KCL laws for these nodes. How can I write it? I have to calculate different current. I define direction for different current in the node. I can write Y1. For example, here I want to consider the all current coming or current leaving. It should be the same. For example, I want to consider leaving here. All the current are leaving. It's a personal preference. Here I considered all the current leaving, but you can consider all the current entering. It's the same. If I consider this one, I1 will be minus I1. And this current, what will be this current? Can you answer? What will be the current in the R1?
V times R1.
The current? No.
V divided?
Yes, V divided R1. And what will be this current in this branch?
Was it V divided by R2 minus I or something?
V divided what?
By R2 minus I or R3, R3.
Yeah, but you can say in this way as well. The current here will be voltage drop across the branch over the resistance. So the voltage here is V, the voltage here is V2. So the voltage difference will be V minus V2. Voltage drop over the resistance. In this way, we can calculate. And according to, it's a KCL. The KCL laws will be 0. Okay? You have this here. I have to write other side. Okay, and if you want to write KCL here, what will you write? I will start it from here. So suppose that all the currents are leaving. The first item, I will start from the current source because they are the opposite direction, will be minus I. What would be the current in this way? What's this current?
V2 minus V over R2.
Exactly. Voltage drop over R2. And what will be the current here?
V2 over R3.
Yes. Or in the more accurate way, suppose that here V4 it's 0. V2 minus V4. V4 over R3. But since V4 is 0 always, so forget it. It's enough. And you can see here, minus I, V2 minus V over R2, and V2 divided by R3 will be 0. However, for us, it's important to calculate V2. Do you think can we calculate V2 with these two equations, or do you need other equation? From this equation, you can see it's the current, it's the current source. So we know it's the voltage source. We know the values R2 and R3 are constant values, and we know that. So the only unknown parameter here is V2. So according to this equation, we can calculate V2. You can see here. It's just some mathematical trick. You can find V2 according to, with respect to the known parameters. All of them are known. The resistor are known, and these are the voltage and current source. When you know V2, you can put it here. and you can calculate I1. The second one will be what VL1. For example, in the exam, the first question will be how to calculate V2 and then how to calculate I1. When you calculate I2, you can put it here. V2. And then you can calculate I1 according to our known parameters. It's one example for the node equation. As you can see, I write KCL here and KCL here. 2 KCL for 2 nodes, and it's enough to analyze the different parameter in the system. It was just an example. Okay, do you have any question? So, do you want to have a break? Or are you enthusiastic to continue?
Continue a bit more, I think.
Okay. Linearity. Oh, did you want to write it? It's written in the PowerPoint. Just explanation.
It's fine. You can continue.
Okay. Linearity and the superposition. These are two concepts that is useful a lot. You don't use directly, especially in the linearity, but it's a very useful principle in analysis of the linear system. And the superposition, you use it as a principle in the analysis of the circuit. For example, what is linearity? Suppose that you have a system. It's a general definition for the linear system. For example, if you insert signal to a linear system as X and you get the response as Y, if the system is linear, if you insert 2X, you will get 2Y. 3X, 3Y. And in the general, we can say if insert Kx, K as a parameter, you can change it everything you want. You will get Ky. It's the definition of the linearity in the system. We use this definition in the circuit theory. It's the definition of the superposition. Suppose that it's very common when you have different sources in the system. Suppose that if a multi-input network, the input X by itself yield output Y. Suppose that you have a system, you insert X1, you will get the response Y1. The same system, if you insert X2, you will get the result Y2. So if we insert X1 plus X2, what will be the result? How do you think? I wrote it here. It will be summations, sum of Y1 and Y2. So it's the meaning of the superposition. It was very mathematical definition, but we use it in the circuit analysis. In which way? Suppose that we have different sources. Here, it's our first source, second source. Analyzing the circuit with two sources simultaneously is very difficult. But we have a trick here, superposition, that give us this opportunity to consider one by one. And then we can sum the responses. For example, at first, you can remove the current source. For example, the first step, remove I, forget it, and solve the circuit, and you will get a result. For example, we want to know what is I1. Without current source, we can calculate, and then, for example, I1 will be 2. In the second step, we'll do in opposite. Remove the voltage source and analyze the system just with the current source. And we calculate again I1 according to system theory. And I1, for example, will be 3. And according to superposition theory, the final result will be I1, it is I2. Or, I mean, it is I1, I mean this one. It will be I1 calculated from the first step and I1 calculated from the second step. 2 plus 3 will be 5. It's a superposition theory. But if you want to calculate I1 simultaneously with voltage source and the current source, is not impossible, but it will be very difficult. With the superposition theory, we can make simple our analysis. It's the superposition. But when I said when you have forgot it in the circuit, it will have different definition. Do you have any question from the previous one? Okay, we can have a break and then continue. 15 minutes. So see you. I have to go out to convert the file.